Go Language Programming, Chapter 3, Unit 1. Slices in Go language. In Go language, slice is a convenient way to allocate variable length sequence of storage in the memory for a similar type of data, such as integer or character or user-defined types. You can not store different type of elements in the same slice. So slice is just like an array with an index value and length, but the size of a slice can be changed, and therefore it is not fixed like array size would be. A slice is not an array. A slice is described as a piece of an array. So slice gives a powerful interface to store data in underlying array. So that's what the slice does in Go language. The slice is a 3-item descriptor containing a pointer to the data that is inside the array, and it also has a length and the capacity. So basically, this is the descriptor which describes about the slice. Okay, this pointer in the descriptor, that the purpose of this pointer is to point to the underlying array. Okay, underlying array, whatever the size that the array may be. So it holds the address, whatever the address of the array would be, it will be in here. So that's why it is pointing to this array. So the slice is nil unless 3-item descriptor is initialized. Okay, so if all these are not initialized, the pointer is not pointing to underlying array, and the length is 0, and capacity, so this is a capacity, is 0, then basically slice is considered as a nil. So it will be a nil slice. Okay. So the nil slice, that means there is no memory is allocated for holding the data. You can create a nil slice using the following syntax. Okay, so this is a syntax that will give you the nil slice. What basically means, when you do this, that only the descriptor will be the one which will be created in the memory, and that's all. And by default, all of these items within the descriptor will be initialized to 0. So this pointer would not be pointing to any address. It will have a nil, and then length and the capacity will also be a nil. So the slice type is abstraction built on top of Go language array. Okay, so when we say on top of the Go language array, that really basically means that once slash is initialized and the pointer is pointing to the array that will be allocated, in the memory to hold the data, then basically, slice in this case, we are saying that it is on top of Go language array type. Okay, it's not like it's really written on top of the array, but it is the pointer which is pointing to that array that was created when the slice was not nil. Unlike an array type, a slice type has no specific length. Okay, so when we went over how to create arrays in chapter 2, you saw that this within the square bracket, you saw that there was a length given for the array. Okay, when you're creating the slice, you don't give any length in here. Of course, you have to tell the type of the slice. So it could be a character type, integer type, or user defined type, whatever, but there would not be any length in here. And that's how you will be able to tell that it is a slice or an array. Okay, so the square bracket will be empty for the slices. So the empty slice has an underlying array created. Now, the nil slice that we talked about does not have any underlying array. It would not be pointing to here, okay, to the array. But if it is a slice is empty, okay, you can create an empty slice just like this. This will be an empty slice, and that means it will the pointer will be pointing to a underlying array. So a slice descriptor pointer points to underlying array if the slice is empty. Use a slice composite literal. So what is a composite literal? This is called the composite literal right here. Okay, this curly braces. So composite literal to create an empty slice. So if you use this composite literal, that will create the empty slice. And if you just right here, if we don't have a composite literal right here, as you can see, so that means it will create a nil slice. If you have a composite literal, it will create a empty slice. Empty slice mean there is an underlying array is created, but it is empty. It doesn't really have anything in there. So composite literal consists of a type of the literal followed by the braces bound list of the elements. So basically, in this case, as you can see, this is a type, okay, of the slice that we are creating. And in this case, we are saying this slice will have these 4 elements. So now, when this slice is created, underneath the array will be created. Okay, and basically, in terms of a descriptor will be pointing to the underlying array. Okay, this descriptor, and the capacity and the length of the slice will be same. Okay, so both will be equals to 4 because there are 4 items in the slice, for 4 integers in the slice. Declare and initialize the variable for slice in a single line, okay, using a slice literal. So here we also declared it and initialized it at the same time, but it was an integer type. Here we are declaring a slice of a type string because these are strings in here. Okay, but for both of these slices, there will be a underlying array created. Underlying array, when it is created, it can only hold one single type. You cannot mix and match the types. So it will always, so in this case, the underlying array will be of type int. In this case, the underlying array will be of type string. Okay. And of course, the underlying array will have this data in there. Okay. So in this case, the slice length will be 3 and the capacity will be 3. And then we can do the same thing. A slice literal is declared just like an array, okay, literal, except no element count, which we already discussed right here. No element count. It is basically empty, okay. And in this case, we are doing the same thing here. We are creating a slice for these 4 strings that underlying array will have. And you can, of course, you can not only have a single character string, you can have a string with more than one characters, and that's what it is showing. But these all 4 examples, when they are created, they are using a composite literal. See, this is a composite literal to create the slice. So in that case, you will have the underlying array created holding the data from this slice. Okay, so let's look at this specific example 3-1. In this example, what we have, we telling that we want to be able to compile this piece of code and create an executable. So that's why we have we start with the package main. Okay, and then of course we are importing the FMT package, and the reason is because we want to be able to use a print line function from that package. And then we have a entry point function in this file, which is main. Okay, and in this case, we already discussed in the last chapter that the start of the block for the main function or any function, the curly braces must be on the same line. Okay, and so that's why if it is on the separate line, then you get a error. Okay, and then this is the end of the function right here. So within the function body, we of course have the comment done in just like you do it in C or C++. So this comment at line number 6, it says cannot create nil slice using a short notation. Okay, so you cannot create, so this is a short notation like we discussed last time, colon equals to. Okay, so you cannot use this colon equals to create a nil slice, because the only thing that you can do with the short notation is if you either use a composite literal, okay, even empty curly braces, or you can use a make function, which we will discuss pretty soon. But right now we know that we can create empty slice. So remember, empty slice is not same thing as a nil slice. Okay, this will let us create the nil slice, meaning there is only this descriptor is there. Okay, and as we discussed in the previous slide, it has 3 things in there. This is a pointer, this is a length, okay, and then this is a capacity. So basically this descriptor will be created right here, not this will be pointing to nil. Okay, so this literally points to nil when you use this way of creating the slice. So slice creation using a short notation, So this is a short notation because of this control equals to, okay? And then we have a composite literal right here, and it will allow us to create a slice. This will be a empty slice, okay? And so once we have that, if we print, then it will be empty, okay? Like right here, this is empty right here. And slice creation using a long notation. So you can use a long notation. This is a long notation, meaning that you are saying, okay, this is a variable of type slice int type, and then you're saying that, okay, you want to be able to initialize or create an underlying array by giving this syntax right here. And then once that is done, at line number 18, we are using a print line function and from the FMT package. And in here, basically, we are checking that if this zip line 1 is going to be equals to nil. So it will result. So you see, it's equality. So it is going to compare. If this is nil, that means this part, the pointer is nil, then it will be true. If it is not nil, then it will display the false. Okay, and basically, if it is nil, it will say true right here. That's what it is saying. Okay, nil equals to true. So that is this part right here, nil, and this will generate either true or false. So in this case, it is generating true. And this is a string that is getting printed right here, zip line. And in this case, since it's nil, there is no data, no underlying array. Okay, so it is just not printing anything in there. And then line 1 is going to be not nil, because why it is not going to be nil? Because right here at line number 13, we are creating a empty slice, okay, by using a composite literal. So it is not going to be nil. That means there will be a underlying array, okay? So underlying array, right, for the slice. That means the array will be created, and this array will be empty, okay? And then line 2, right here, we are actually creating the longer way, not the short notation. And at the same time, we are initializing the slice. Okay, the line 2 is a slice. So we are initializing it by using this composite literal, and assigning some data to it. So the slice will have the data. So that means the array, underlying array, will have some data in there. Okay. Now, what exactly happens when you give a number of data? Underlying array, okay, of course it will have this data in there, 1 and 2, but the array itself could be bigger. Okay, it won't. So that is up to the compiler. The Go compiler basically decides. So if you give just only 2 items, that doesn't mean the underlying array will only have 2 elements. Okay, it might have the double the size of the elements, okay, or 3 times the size of the element. So it's always depends upon the compiler, how the compiler will do that. And also, one other thing in Go language is that these memory for this gets allocated either, so as you know that there are 2 types of memories, right? One is a heap memory and the other one is a stack memory. So it's up to the compiler for these things. compiler decides, okay, does it wants to allocate the heap memory or it wants to allocate the stack memory. So you don't know if this array will be in the heap or on the stack. So we cannot tell. Okay. So that's how it works. And I think I went over that in the last lecture as well. And I gave you how to compile that piece of code to find out if it was the memory was allocated in the heap or not. Okay. So anyway, so these last two print line basically will give you the the results. So this one, since line 1 is also nil, so that's why this is false, and line 2 is nil. So in both cases, that means it does have a underlying array. Okay, and basically it is going to um, uh, display what you see it right here. Okay, that really concludes unit 1, and we will go over unit 2 and discuss slice operator syntax.